We begin with the part 2 for the 11 Elite. This is the multiple choice question part. Question 6 is to write a vector as a linear combination of unit vectors. We have been told in this question the initial and the terminal point, that is D and D, that starting point and the ending point is given. We need to write the linear combination of the vectors I and j. Basically, you have to just find the component form. See, x1, y1, x2, y2, right? How do you find the component form? For the x-axis, it's x terms. It'll be 5 minus 4. And the next one is minus 7 minus of minus 1. That is it. You can see it is 1 comma minus 6. This is the component form. You just write 1i minus 6j. This is the linear combination. You're combining these both with I and j. That's it. I is like the x-axis, j is the y-axis. Simple as that. Here also you can directly do it in your mind because it's electronic. You don't need to write anything. Minus 7 minus 9. So what happens is it is 16 minus 16 and 2 minus of minus becomes 8, positive 8. So that's it. Please do the others by yourself. The second term minus the first one, or your second term minus the first one. The first one, x-axis, x terms would be I and plus the j terms. So you can just put in your calculator, we at 0, so it's 0 minus 9.5 would be minus 9.5 and minus 7.3. Minus of minus becomes, you need to add it and write minus sign. Similarly here as well, very easy problems. And let's, even if it's a fraction, it's fine, it's same thing. Now you can use your calculators over here and keep it in fraction itself. See, it's minus 4 minus 1 by 8. And then we have 2 by 7 minus 3. Don't write in decimal. Your answer would be in fraction itself generally, okay? So here, it's up to you. You can multiply 8 and 8 and you can solve it. Here the answer, you can see it's written in fractions. So leave it in fractions itself. No need of writing in decimal because they are given in fraction. Over here, they are the same. Literally, the starting and the ending point is at the same point. So what happens? There is no component form. It's 0 and 0, right? So because you start and end at the same point, that's why it's 0. Now we have real world problems. Commute. To commute to school, Larisa leaves her house and drives north on Al Nasser Street. So let's see over here. From here, you should know this. North is always above, south is below, right side is east, and left is west. So north is up, down is south, right is east, and west is on the left side. Here let's draw north because she's driving north. It's like a straight line upwards. How much is that? For 2.4 kilometers. Okay. And then she turns left, that is to the west. How much? It is 3.1, so it should be bigger. 3.1. And then again she turns right. See, now she was going north, left, and now right from west would be again north, isn't it? And that is about 5.8. Now express Larisa's commute as a linear combination of unit I and j. So when she starts, we consider it to be 0 and 0. Where does she end? This is y-axis. Again, this is also y-axis. So 5.8 plus 2.4. It'll be 8.2 here, the total distance traveled. And what about, that is the y-axis. Now upwards, that's y. X and y, right? What about the x? It's minus 3.1. Why is it minus? Because we are going to the left, isn't it? Left side would be considered negative, right would be positive, up is positive, down is negative. So if it was south, we would have considered this negative. Now it's the same thing, initial, this is x1, y1, x2, y2. You just subtract 0 minus of minus 3.1, and then what you have, 0 minus 8.2. So this is the component form. It will be 3.1. I'll directly write it as I plus, sorry, it's minus because negative 8.2j. So that's the answer. I hope that is clear. It's minus 3.1i, my plus. Okay, here, what happened? Here it is y2. It's y. Oh, now you can see the formula. I have just messed it up. Here you can't just interchange the formulas. It's a good mistake that I did over here. I'll keep it as it is. I won't edit the mistake out because I did y1 minus y2. This is the issue. It is, what is the formula? It's y2 minus y1, x2 minus x1. That's the component form. This is over here minus 3.1 minus 0, and we have 8.2 minus 0. So the answer is minus 3.1 I plus 8.2 j. So the signs would have changed because I took the other way around. Okay, so it's minus 3.1 plus 8.2. I hope that is clear. Another similar problem, Nadia is rowing across a river at a speed of 5 kilometers per hour perpendicular to the shore. Now they're not told, which direction or anything, but let's consider this to be the shore, and perpendicular would be straight line making 90 degree. Nadia is rowing 5 kilometers. Okay, perpendicular. The current. Now this is a vector because see here, this has kilometer per hour. It's just not the distance. It is kilometer per hour. So this is a vector over here of 5 kilometers per hour. And then what is the river current? The river current is given as 3 kilometers per hour downstream. So now if this is the shore, right? We are perpendicular to it and it's going downstream. You can just do it like this. It's going, whichever direction it's going. So 3 kilometers per hour. Now that means entirely, now this is the force of the water that is pushing you to the right. So now what happens? You're trying to go perpendicular, but you've been pushed by the, the river speed. So you tend to change your direction for a certain angle, right? It goes something like this. You reach over here. Now, what is the resultant vector? That would be the speed you would be actually traveling, because you want to go in 5 kilometer, but there is other forces that is acting on you and you can't go. So you change your direction by a bit and your speed also reduces. There is a loss of speed as well. How would you find this vector? Very simple. Magnitude of this vector. How do you find magnitude? Is by just take the square root and sum of the square. Pythagoras theorem, if you remember, this is 90 degrees. It's 5 squared plus 3 squared here. That's it. That's 25 plus 36. Sorry, 34. Square root 34 is the answer. That would be the resultant vector. Now I'll just give it as VR, resultant. And this is the speed she'll be traveling in basically. Square root of 34. It's less than, see here, 5.8. Now there is one thing I told, there'll be loss of speed. But look here. You're going, imagine you're going in this direction and wind is blowing at your back. You're running in this direction, okay, and the wind is blowing at your back. So your speed would increase, right? Why? Because you're getting easily pushed by the wind. Whereas you're going in the same direction but the wind is against you, then your speed would reduce. Now here you're trying to go there, but it's being pushed at you, so you would be gaining. See, now it is not, it is helping you, the wind is helping you, so the resultant would be just a bit more. So the resultant is basically she's traveling in 5.8 miles per hour. If it was opposite to her, then it would be reduced. So here square root 34 is 5.8. That's the magnitude. You can see this is an electronic part, so you don't need to write all this in detail. Just directly you can find it out. And then at what angle is she traveling with respect to the shore? Okay, we need the diagram. What is the angle here with respect to the shore? So, this is phi. Over here we have 3. Which angle, trigonometric function can you use? That's opposite. Hypotenuse is unknown. I mean, hypotenuse is known, but the opposite and the adjacent. So we always use tan in such cases. Always to find where, you might know theta for the angle is of a vector is given as tan inverse of phi, the vertical side, by the horizontal side, phi by 3. If you just put in the calculator over here, you get the answer. Let us use a calculator's shift and tan. Use your tan inverse. Okay, it's phi divided by 3. And that's the answer. It's 59 degrees. You can see here. That's the answer. That's it. So this is how easily you can solve this one. And that's the end of question 6. This was an easy topic. I hope it's all clear. If you have any doubts, please post them in the comments and I'll try to get back to you very soon.